7.4. The water potential of the blood plasma is more negative at the venal end of the capillary than at the arterial end of the capillary. Explain why. And this is because at the arterial end you have the high hydrostatic pressure, and the hydrostatic pressure is higher on the inside than the outside, and it's also higher than the osmotic pull. Therefore, the water is going to leave the capillary. The tissue fluid will be formed, but in this question we're talking about the water potential, so it's best that we talk about the movement of water. So the water has left the capillary due to that high hydrostatic pressure at the arterial end, but the proteins that are inside of the capillary are too large to leave the capillary because it can't get through the pores. Therefore, the water will leave the capillary, but the proteins stay inside. Therefore, you've now got a higher concentration of blood proteins because you've got less water. There's still the same amount of proteins in the venal end as the arterial end, but the water has moved, which is what will affect the water potential. So because the water has moved out, you've now got less water with the same amount of proteins, therefore you've got a higher or an increasing concentration of blood proteins. So that therefore means you've now got a more negative number at the venal end because you've got a lower water potential inside of the capillary.